So let's actually build our first Unreal project. And our first project will be this dividing cell grid that you've seen in the teaser image. Now, this will be a two-parter. In the first part, we're going to build our base setup, and you can watch this right here for free on YouTube. In the second part, we'll make our animation look a lot nicer, and this is something that we'll publish on Patreon. But now let's take a look at this setup right here. And before we actually jump into Unreal, I first of all want to talk a little bit about the differences between working in Unreal versus working in Houdini. Let's maybe start with the Houdini side first. And if you would build something like this, an animation like this in Houdini, what we will probably do is do a ton of work first, creating a bunch of points and putting a bunch of attributes onto those points. And we're going to build one massive setup that is really, really good at manipulating a bunch of points and making them do stuff. And then finally, once we have a bunch of points, all the rest is basically just a copy to points. And then we have actually renderable geometry. This is the Houdini way. Unreal is a lot different because again, Unreal is a game engine. And what game engines usually do is they have a lot of NPCs, non-player characters, little robots that do stuff, and then also one player that can interact with those robots. And if we build setups in Unreal, it's much easier for us to also stick to this convention. So how could we imagine building this Cellgrid setup in Unreal? Well, in our case, we want to build quite a simple setup. We just have one NPC, or one actor, as Unreal calls it, and one player, or one pawn, as Unreal calls it. And the NPC, the actor, this will be simply one cell of our grid. And our pawn will actually have no shape at all. This will be just our input into the world, and we're going to talk about what this input will be in the end in a second. But for now, let's focus on this actor right here. Now, at some point, this actor will spawn into a level, right here. For example, if we hit play. And once it spawns into the level, I want to have it do two things first of all. You should first of all choose a specific shape, or one random shape, and then also one random color from our palette. And for now, this is actually complete yet. Now we have one grid with different cells, and each cell has a different shape and a different color, which hopefully should look beautiful. Now, to make this actually interactive and also more interesting, at some point we want to register if we, the player, click onto a cell. And once we click onto a cell, what we want to happen is we want this cell to divide into 4 new cells. And now these 4 new cells are going to get spawned, and they're basically now we're right here where we left off. So they can again choose a shape, again choose a color, and then again wait to be clicked and then subdivided. And this is the entire logic that we want to implement today. First of all, let's go into our Epic Games launcher right here. And let's duplicate, first of all, our base project. So let's right click it and select clone like this. Let's give it a name. Let's call it, in my case, Rec Cellgrid Part 1. Let's also give it a version number like this. And then hit create like this. Now we get a warning by duplicating the base project. We can pretty much ignore this, so let's just hit continue right here. And now we have our Cellgrid project, and we can just double click it to get to our Unreal editor. Now inside our Unreal editor, the first thing that I want to do is in my level, I want to get rid of those 5 temporary spheres. We don't need them, just delete them. And I also want to make this base grid a bit bigger. Let's maybe scale it up to a value of 20 instead of 10. And now I want to open up the content drawer. Also, one tiny thing that I forgot in the last video, one mistake I made, is I put my BP pawn, my pawn blueprint, into the standard blueprints folder. I want to move it into the BP folder. Let's move it right here. And then we can also get rid of this blueprints folder, just delete it. And now we have a pawn and a game mode in here. And next I want to recreate my geo folder like this, move it into the content folder, and then into this geo folder I basically want to import 4 meshes, which will be the 4 shapes that I want to work with. And you can find those meshes also in the scenefile downloads. I'm just going to select those inside another Explorer window and just drag them in. Then this dialog box opens and we can just hit import. The default values should work fine, and now we have 4 shapes in here. Now with this done, we can finally jump into a blueprints folder and actually create a blueprint actor. So for this, I'm going to right click. I'm going to select a new blueprint class. I want this to be an actor, like this. And let's call it BP_cell, like this. And now with this created, let's double click it. And we get this blueprint editor window open right here. Let's take a quick look at this. In the middle, we still have our 3D viewport, and we can again hold the right click button and move around with WASD. However, in this case, we probably want to turn down the camera speed a bit up here. Let's maybe just make it 1/3 like this. Then up here, we have a scene graph tree where you can add new objects, and I want to do this right away. I want to simply open up my content drawer down here, go into my geo folder, and let's, for now, drag in the torus. And now we have also this torus inside our blueprint, like this. What this actually did in the background is it created one static mesh in here, or one static mesh component, and on that static mesh component is the actual static mesh of a torus linked in here. And I actually want to rename this, so let's simply call it cell, like this. Down here we have some additional stuff, most importantly variables, which is something that we're going to talk about in a bit. And on the right side here we have again the properties of the object that we have currently selected. And then finally up here we have some tabs, and on those tabs we mainly care about the viewport and the event graph. The event graph is where we're going to build all our logic. So let's do just this. Again, as I said earlier, as soon as I want my actor to spawn in, so as soon as this event begin play box right here gets active for this actor, I want this actor to choose first of all a random shape and then also a random color. Now I actually already have some random shapes, these shapes right here, and I also already have some random colors or material instances right here that we built in the last episode. Now I just have to find a way to have them linked in here in our node graph. And this is actually where I want to work with variables in here. Now, variables are a bit of a special case inside Unreal, and they have lots of uses. One of those uses is to simply store values. These might be some float values or some vector values, or in this case, references to some objects and some materials. And later I can use those variables inside my code in here and actually make them do stuff. So let's add first of all a variable for all of our shapes. Let's click this plus button in here. Let's call it shapes. And let's select the data type. Currently this is a Boolean. However, in this case, I want a static mesh like this. And in here I have a couple of selection options. For now and for pretty much most cases, what I want to use in here is an object reference. Let's click this. This is just one single shape or one single static mesh. However, I want to be able to link in multiple of those. And to link in multiple of those, what I can do is come up here to this drop-down menu and select, instead of single, select array like this. Now to actually see some changes in here happening, what I have to do is I have to hit this compile button up here. And we basically have to hit this compile button whenever we're doing any changes to our code in here for this to take effect. But now in here, I have this little menu, and since I have 4 shapes, I can hit this plus button on this menu 4 times. And now I have these 4 inputs for my 4 shapes. And I can bring up my content drawer, go to my geo folder in here, and simply drag them in. Let's do the same for our materials. So another variable, let's name this colors. Now this won't be a static mesh. This will be a material instance like this, because this is what we built in the last episode. And again, this will be an object reference. And again, this will be an array like this. Let's hit compile again. And since we have 5 materials, I'm going to hit this button 5 times. And again, bring up my content drawer, go to the mat context, and simply drag in my 5 material instances. Now, finally, when we begin this play event up here, I first of all want to get access to, let's say first of all, these shapes. I need to get access to this variable, and I can simply get this by just dragging it in. Now I have the option to either just get the values inside this variable or to set those values inside that variable. In this case, I just want to get them. I have this node right here. And then with this node, I want to find out how many shapes I actually have, because in the future, I might want to add more of them. I can find this by dragging out from this node and searching for last and getting the last index node, like this. And then I can use the output of this node to actually get a random index, to grab a random shape from our array. And this will be a random integer in range. Now I don't want to connect the last index to the minimum input, I want to connect it to the maximum input, and I can simply do this by holding Control on my keyboard and then grabbing the input from the minimum and connecting it to the maximum, like this. Now this will generate a number between 0 and the last index of our array in here. And then we can use this number to finally get one random entry from our array. So let's drag out here and search for get and use the get node and wire in the index in here. So with this little code in here, we're just grabbing one random item from our array. And now finally, we want to use this item, this static mesh, to change this static mesh in here. And I can do just that by dragging out from here and searching for set static mesh like this. And this already recognizes that we have one static mesh component up here called cell, and we might want to change this. So it already suggests this for us and also already connects this node to it right here. So we can drag this out and finally connect the one entry from our array to a new mesh in here. This is the first part done. Now the second part is to set one random material, and you might have guessed it, this will be quite similar to what we did here. So actually I'm going to just take these three nodes and just hit Ctrl Z and Ctrl V and move them over like this. And then I want to get access to my colors. So let's drag this in from here. Let's get our colors and let's wire them into the last index and also the get node. And finally, to set our material in here, we again going to search for set material in this case. And again, we're going to grab the cell option like this. Wire our main action graph from here into here and then our material into here. And this is our entire node tree for now done. Now we have to talk a little bit about the structure here, because this is somewhat different to Houdini. What's mostly the same as in Houdini, at least as in Houdini VOPs, are those little noodles in here, because they transport values. What's new with an Unreal are these noodles right here. If you're coming from Houdini, you're used to that you can have a lot of nodes be processed in parallel or one after the other, and then just merge all of those outputs into one single geostream at the end. Unreal is a little bit different in that case. Unreal always wants to have some nodes executed in a certain order, and this connection that we're drawing right here is this special order. So we're starting first out at our event begin play. Then we're going to set a static mesh. This gets all its right values from this node tree right here. Then we're going to set a material. This gets all the right values from here. And then we can move on to, well, something else. But for now, this should be working fine for us. Let's test this. Let's hit compile. Let's close this window right here. We should also drag at least one of our cell actors into our actual scene. Let's drag this in here and let's center it. And then let's hit play and let's see what we get. And yes, we get one random shape and one random color. Let's play again. Another random shape. Again, another random shape and another random color. And another random shape and another random color. So this is clearly working. Now, before we can actually move on to implementing clicking on an actor and dividing it, I actually want to clean this up a bit, because this right now is somewhat hard to read. And we're also going to add a lot more to this event begin play later in the second part. So to clean this up a bit, what I actually want to do is I want to add a custom function, a custom event, to change the static mesh and the material or the color, and then just have one box up here to execute all of this. So to do this, what I'm going to do is I'm going to right click and search for add custom, and I want to add a custom event, and I want to call this event set shape and color like this. And now I can disconnect this connection right here by again holding Control and dragging out, wire this in here. Now I can take all of this and move it out of the way. Let's move it down a bit, and let's also grab the second part, the color, and just move it down like this. Now I think this is a lot more readable. And then to use it up here, all we need to do is drag out a noodle from here and search for set shape and color. And now as soon as our execution graph right here hits this node block right here, Then all of this down here gets executed. Now we're done with our base setup. Now let's actually talk about how we're going to, first of all, click on our actor and then also make our actor divide into 4 new actors. Now, let's first of all worry about clicking on an actor. How can we do this in Unreal? Well, since this is a 3D program, this is a bit more involved, but fortunately for us, Unreal does a lot of the heavy lifting for us here. What gets done in the background is something you can imagine like this. We have our camera somewhere in a scene, and glued in front of that camera is basically a view window where we're looking through. And somewhere inside that view window is also a mouse cursor. So if we want to click on something, what Unreal basically will do in the background is shoot one ray out of the center of the camera through the tip of a mouse cursor. And if that ray happens to hit an object, then we clicked on an object. So this is the next thing that I want to implement in here. And once we do click on an object, we want to add a new function to that object to split it into 4 new objects. So back in Unreal, we're done for now with our blueprint cell. Let's hit also compile in here and also save. And now to actually interact with our cell, we have to work on our pawn. Again, the pawn is the way how we can interact with the world that we're building in Unreal. Let's double click this. Right now, this is a very reduced window. We do want some more options. So up here, I'm going to click Open Full Blueprint Editor. And now we basically have the same menu as with our blueprint actor or blueprint cell up here. Now, the first thing that we want to solve is something quite simple. If we hit play and click in a viewport, our mouse cursor disappears. And we don't want that. So let's first of all make sure that our mouse cursor stays visible. For this, let's jump back into the event graph of our pawn. And we want to work on the event begin play. So once we hit the play button, and I want to drag out from here, and I want to search for show mouse cursor, and it's currently not finding anything. Let's turn off context sensitive, and in here we can choose between get show mouse cursor and set show mouse cursor. We want to set our show mouse cursor like this. We obviously want to set this to true. We want to show mouse cursor. And then also we need to specify a target in here. And in this case, the target will always be the player controller. Basically, whenever we're dealing with any input, we need to get at some point our player controller to be able to read those inputs. So I'm going to drag out from here and search for get player controller like this. And now if we compile that and start our game again and click inside our viewport, now our cursor stays visible. Now back to our pawn. What we now want to do is we now want to register if we clicked onto an object. So for this, I first of all want to register if we even clicked the left mouse button. And I can do this by right clicking and searching for a left mouse button. And in here under mouse events, we have the left mouse button. And in here we have 2 events. It's either pressed down or it's released. The node that we want to use in the end in this case will be a line trace. This will be this shooting array out of the camera through the mouse cursor that I talked about earlier. And in here we want to use a line trace by channel. Now this line that we want to trace needs a start and an end point. And the start and an end point is something that we can get again from a player controller. So again, I'm going to search for get player controller. And dragging out from here, I can search for convert mouse location to world space. And now I have both a world location, so where my mouse is in 3D space, and a world direction, so in which direction this ray is shooting. And now I can plug this into this and this into this. Or not quite. First of all, the world location can go directly into the start. This works fine. However, this does not want a direction, this wants an endpoint. So we do have to add a world location and a world direction together like this. However, we are also not quite done here because the world direction is just a vector with a length of 1. And Unreal uses centimeters for scene units, so this is a very, very short line that we're drawing and this won't hit anything. So we have to multiply this line as well to make it long enough. Drag out from here, search for multiply, and I could just add one value in here and here and in here. However, this is quite tedious. So I'm going to right click this and convert this vector parameter to a float parameter like this. And then I'm just going to add one very large value in here. So let's maybe make it 10,000 like this. And then wire this into the add. And now this is actually working. And to test if this is actually working, what I'm going to do now just as a test is if I hit something, I want to print a string. And what I want to print out is either true if we hit something or false if we don't hit something. So let's wire this in like this. Unreal in here adds this little conversion node to convert this boolean into a string. And then let's hit compile. Let's minimize this window and let's see if this actually works. And if I click now in here, I get true. And if I click here, I get also true. Why is this the case? We're still hitting something. In this case, we're hitting the background. In this case, we're hitting our cell. The difference is just, this is something that we don't want, this is something that we do want. So let's fix this. Let's for now get rid of this node and let's also disconnect this node. Let's move it out of the way. And now let's take a look at this thing right here, this out hit parameter. And this is actually something that Unreal Engine likes to do quite often. It likes to cram a ton of info, a ton of values into one single noodle. And we can actually enlarge this by either selecting split struct pin here by right clicking or just dragging out and saying split struct here, I think. Well, let's just right click it and split the struct pin here. And now we have all those outputs right here. And the one thing that we care about here is the out hit actor. Because with this we can check, hey, did we actually hit our cell or did we hit just anything else? And to actually check this, I can drag a noodle out from here. And the node that we're going to use in this case is a bit strange, but bear with me. This node will be cast to BP cell. And what this simply does is it acts like a filter. If our object is actually a BP cell, then our execution graph will continue up here. If it's anything else, then the cast will fail and it will continue down here. So finally, what we can do now to check this is again connect our print string. And in this case, just print hello if we click on our cell. Let's hit compile again. Let's hit play in here. And if we click on a cell, we get a hello. If we click anywhere else, we don't get anything like this. So what we can finally do now to make this all interactive and actually interesting, instead of printing something out, what we can actually do is grab our cell in here, the one that we clicked on, and also run a function inside of that cell. So for example, either a split function that we're going to build in a second, or also our set shape function. And let's actually try this. Let's drag out from here and let's search for set shape and color. This is the function that we built. And now if we hit compile and make this small and hit play and click on our cell. Now every time we click, we change the color or the shape or both. But of course, this is not what we want to do in the end. What we want to do in the end is be able to divide our cell into 4 new cells. And now this is exactly what we're going to do. Let's go back to a BP cell. Let's go way down here and let's right click again and add another custom event. And let's call this event split like this. And now let's quickly talk about what splitting a cell into 4 new cells means in the end. Back to diagram land. So what we want to do in the end is we want to take our old cell, this cell right here, and we just simply want to delete it. And in its case, we want to spawn 4 new cells. 4 new cells that make this perfect 4x4 square or 2x2 square. So how do we get there? Let's first of all take a look at what we know about our old cell. It definitely has a position right here in the middle, and it also has a size. And I know that the cells that I modeled all have a size or fit in a square of exactly 200 Unreal units, 200 centimeters. And of course, since we're going to scale our cell up or down, this 200 units gets multiplied by our current scale. So how does that change? How do both of these values change if we create a new cell? If we create this cell right here? Well, the size is quite easy. It's still going to be 200 times the scale. However, the scale is now divided by 2 to just make it half as big. And to set a new position, what we basically want to do is we want to start out at our old position and then move either to the left or to the right and then up or down a certain distance. And with this, we're going to arrive at either this location or this location or this location or this location. And the one thing to keep in mind here is that this distance right here is exactly 1/4 of our actual size in here. So 50, and again times our scale. 50 units to the left, 50 units up, and now we have a new location right here. So in the end, as a formula, this looks like this. Our scale new is our old scale divided by 2. And our new position on the x-axis is our old position on the x-axis plus or minus 50 times the scale, plus will move it to this side, minus will move it to this side. And our new y position will be our old y position plus or minus 50 times the scale again, which move it either up or down like this. And we have to do this 4 times to get our 4 new cells in the end, and then we have successfully divided our cell. Let's implement this right here. So first of all, since we're going to create 4 new cells, we're going to first of all need a couple of for loops. Let's search for for loop and let's grab a for loop down here. And I want this for loop to run 2 times to create, in this case, a first row and a second row. And this for loop should run from an index of 0 to an index of 1, like this. And then for every loop iteration of this loop, we want to add another for loop, which again will run for 2 iterations, since 2 iterations times 2 iterations is 4 in total, so 4 copies. And then for every loop body in here, we want to spawn a new actor. We want to spawn a new cell. So let's search for spawn actor from class, and the class will be a bp_cell, like this. And then in the end, once we've spawned all our actors, we want to delete our original actor. So this will be this output right here of the first for loop. And I want to branch out from here and search for a destroy actor. And the actor that we want to destroy is ourselves, like this. And now again with the spawn actor, we have the input transform or the spawn transform where it should spawn. Right now, this is just one single input. I want to expand this, so right click this and again split struct pin. Now we have a location, a rotation and a scale. And I now want to plug in the right values into the scale and into the location. Again, the scale will be the simple one. First of all, need to get the current scale of our current actor. And for this, I'm going to use a get actor scale 3D node like this. And again, I'm going to multiply this. Again, I'm going to join those 3 floats in here into a single float like this. Make this a value of 0.5, make it half as big, and then wire this into the scale. And we're done here. Now, the location will be a bit more difficult. Let's make a bit more room here, because again, we want to start out at our old location, and then to this old location, add a new direction that we want to move in, to move a new actor into each one of those 4 corners. So first of all, let's get our actor location, like this. And to this vector, we want to add something, add a new vector that we're going to build. And then this will be connected to the spawn transform location, like this. And now let's build this new vector. And I want to construct this from those index values in here. So first of all, let's take those index values and actually convert them into float values. Let's search for float and let's use a toFloat in here to convert the integers to floats like this. Let's hit Ctrl Z and Ctrl V, get another one, and let's wire in the second index from a second loop like this. Then those indices in here are between values of 0 and 1. And I want to get those into a value range of -1 to 1. So what I want to do next is drag out from here. And first of all, add an add node. And to both those, I want to add a value of -0.5, like this. Because this will shift our value range now from -0.5 to 0.5. And then after that, I'm going to multiply it, and I'm going to multiply it by 2. And now we have a value range between -1 and 1. Again, let's copy those values, and let's wire this in here like this. And now we have 2 values between -1 and 1. Next, I want to take those values and actually get the right distance that I want to move each object in here. So let's make some more room in here. And let's drag out from here and get a multiply node. And I want to multiply this first of all by the value that we calculated earlier. So 1/4 the size of our original object. So 50 Unreal units in total. And then I also want to multiply it by the scale. And for this, I want to take my actor scale in here. And I first of all want to break this vector into floats, and then I can just use the x value. These are all the same values on the x, y, and z axis, and just plug this not up here, but down here, and let's make sure that we keep this at 50, like this. And let's make some room here. Let's again copy this node and do the same for another axis, like this. And then finally, with this done, we can combine both of these values into a vector by searching for make vector. And this goes into the x-axis and this goes into the y-axis. And then finally, we can take our new vector and add this to our actor location like this. And now this should actually all work. This is our entire node tree done. Let's test this out. Let's first of all hit compile. Let's make sure our pawn is also compiled. And also in our pawn right here, we don't want to set the shape and color. Instead, we want to drag out from our BP cell and search for split like this. And hit compile again. And now let's keep our fingers crossed. Let's hit the play button in here and let's click our cell. And this looks very promising. And this looks also very promising. And yes, now I can keep going and make those objects smaller and smaller and smaller again, which is exactly what we want. So this is it for this video. This is running long enough. In the next video, we're going to add a ton of little animations to all of this, make it look a lot more lively. And then also I want to be able to simply draw on my shapes and basically turn this into a fancy canvas where I can draw not by lines, but by subdividing shapes. But this is it for today. And until next time, it's cheers and goodbye.